Hello, internet friends. I had the pleasure of chatting with Corey, a local kiln tech. We talked about manual electric kilns, slip casting, glazes, thermocouples, microcontrollers, and of course, PyKiln. Here is a recording of our conversation. Enjoy. What sort of background do you have in ceramics? I know your wife is a potter. You do stuff with like enamel too. Tell me a little bit about like your setup at your house.
Actually, we have an external building that is her pottery studio and gallery. Now, say hello, Sylvie.
Hello.
Hey, Sylvie.
That's Sylvie. We built a building for her to have her pottery studio and gallery in. And when we were building this, we took time to plan a kiln room that was specifically for kilns. It had enough power in it and the whole works. That's also basically a fireproof room.
Yeah.
What she does in there, I mean, obviously she makes pottery. The kilns are basically used for pottery work. The little tabletops are used for a little more than that. I do glass bead annealing.
Okay.
I make hand lamp work glass beads out of soda lime glass, so soft glass.
Oh, that's cool.
And we've done a little bit of enameling. We've actually done an experimental. We made glass
from scratch, like sand and mixing in
sand and soda and lime.
What color did it come out as?
This was clear. It
was clear.
Okay. Yep. But I had to stop the process. Had to stop it a little short because the piece of stoneware that I was using as a safety barrier between the bottom of the kiln and my little aluminum oxide. My crucible had become too soft and was starting to warp.
Oh no!
So I had to stop it early. So it's only about 3/4 of the way reacted, but it was going to come out clear.
Okay.
And that was doing it without temperature controls. That was just guessing.
Oh, okay. Is it an electric or a gas or was it a microwave kiln?
No. These are tabletop kilns. They're 10 volt. What they are is basically 2-element kilns that are regular fire brick and everything else, but they're only 8 inches wide by 8 inches deep by 4 to 6 inches tall.
Okay.
For the firing chamber, so you can reach high temperatures very easily.
So how you said that you were just guessing? Is there no like temperature setting, or is it just like a knob? How does that work?
It had been low, medium, or high, and we had 2 of these. One of them has a pyrometer on it. I wasn't using that one. That's the older one of the 2, and I would have had more. I'd have been a little more leery of damaging elements going high enough to actually react glass components.
Yeah.
The other one was, I tell you, you really got to watch Goodwill. We got this other one out at Goodwill for $30.
Do these have brand names on them at all, or
No.
No.
Actually, the old one does. That's the one we found at when I was shopping for the gas stove. It has a brand name on it. It was actually manufactured in Akron, Ohio.
Oh, okay.
Okay. The newer one of the 2 was found at Goodwill for $30, and a friend of ours found it, called, said, "Hey, you want this?" I said, "Sure."
Yeah, I have 2 kilns myself. One I bought like full price, brand new, and it's small-ish. It's like enough to do like a small load of pottery. And then I have a larger one that's a manual electric kiln that I got off of Facebook Marketplace for like $200. And
good deal.
Yeah, I mean, all the elements work. She had all the kiln shelves. The bottom is a little bit damaged, but like I think it'll be okay. I'm planning on like taking that one and redoing all of the electronics on it. Adding a couple thermocouples and putting PyKiln in it. Yeah, but I'm kind of like, I would like to do a small tester kiln, kind of like the ones that you have too, just to start out with and experiment and like do more like even just testing PyKiln itself, you know, because it's a smaller chamber. I don't have to heat up as much, and it just makes the whole process easier.
I'll tell you, so we've also got two larger kilns. One's a 17-inch by 23. That's the inside. And the other is 27 by 20. Okay. 27 wide by 20.
Pretty big.
Actually, I think I sent you the dimensions, but my memory's not good on that part. But they're good size kilns. So those are full size, and she fires them often.
Yeah. What sort of controllers do you have in those?
So the smaller one is a Crest, and it has what they call Firemate or Pyrometric. It's just basically ramp. It's basically just a ramp controller with a timer and a sitter. Okay. And the larger one has electronic controls that are just one step above that. You can set a percentage of power and an approximate time rate. You still have a timer and you still have a sitter.
So, okay. I've never actually fired a manual kiln. The one kiln that I have, I'm still pretty new to ceramics. I'm just starting to get into it, but I'm a software developer, and I was like, I have the Bartlett 3-key controller, and it's just like awful to use. You're just constantly like reprogramming this tiny LCD, and it's like switching between different things. So like, after that, I was just like, I need to fix this. This is awful. And there was like no good open source solutions that were out there. There's a few out there, but like they just weren't quite right. I haven't
seen. I haven't seen any commercial ones that I particularly cared for.
I mean, there's like the Scott one, which is pretty good, but it's still not great. And then there's the Tap Even Heat one, which is okay. It's still just like, it seems like a very crude process, and like, it's not very easy to work with. And like, you know, what I really want to do is make it a joy to use. So it's like, oh yeah, of course, this was the process. And you can see, you know, the firing schedule and where things cool down. And, you know, you can have multiple zones, and you can see like, oh yeah, the top and bottom are too cool. Let me add, you know, 10% to the top and bottom so that they're a little bit warmer. I want to make like the Octoprint of kilns. I don't know if you're familiar with like 3D printers, but like that's essentially what I'm trying to do. But like, can you actually like tell me like what you have to do on one of your manual kilns in order to get the temperatures that you like, and like what sort of issues you run into and that sort of thing?
So one of the biggest problems you have with manually fired kilns is overfire or underfire. Okay. Now we all know that ceramics are based on heat work, which is temperature over time. Orton makes these things, pyrometric cones. Okay. And they're really good at measuring heat work. What they're really not good at is telling you what your temperature was when you got to the heat work and the length of time it took you to get the work done. So they're just telling you that work has been done. Now those cones,
you hit it at some point.
That's right. If that cone is thinner than your piece of pottery and you overshoot the temperature so that cone melts quick, that pottery didn't have enough time to soak and is underfired, but the cone says you overfired. So there's some variances there too. The other part is that cones or kilns with sitters, these little pyrometric bars that bend, that turn, they also have to experience the heat work, and you can have problems with that as well. They go out of adjustment.
Interesting. So that makes perfect sense. Like you're heating up a tiny piece of ceramic, and that's going to heat up and cool down a lot faster than, like a quarter to a half inch thick, like pot,
So if your ramp rate was too high and your power settings on your kiln was too high and you overshoot the temperature, you can accomplish the heat work in that little pyrometric cone before you've actually heat worked your ceramic, your pottery.
That's crazy to me, because like the whole point of like these little cones is to be like, oh yeah, my ceramics are good, but really it's like you need to go maybe like another cone or two higher.
So you're supposed to have a witness cone above and below,
right?
So you know where it has fired.
I see.
Okay. That one example I gave you is very rare. Most of the time, the cone is a good reflection of how you fired, but you can still, with the bar and the sitter, you can still misfire. So you come out and your cone's only been over that far, that's an underfire. Or if it's flat like this on the ground, it's a overfire.
Yeah. So a perfect fire is it's just like touching, right?
Just touching. It's 100% been over and just touching.
Okay. I'm going to have to get me some cones. I don't have any yet.
I'll tell you, in the area, we used to be able to go to, I'm going to use their name. So
there's
Ohio Ceramic Supply.
Yeah.
Okay.
I've been there.
You can't go there anymore.
Really?
They're closed.
Because of COVID?
That's the one in Kent. Buckeye Ceramic Supply, which is also owned by Mako, is down in Columbus. That's open, and you can have it shipped to Ohio Ceramic Supply, so you can do pickups, but they're not open to walk through anymore. So
okay,
there's a really nice place in Toledo. It's called the Art Depot.
Okay,
it's in Pennsylvania, Ohio.
Okay.
You can walk in there. It's called the Art Depot in Sylvania, Ohio.
Okay.
And the owner's a really nice lady. She's a pleasure to deal with, and it's an easy to get to. So that's a really nice place to go. Like I said, the other options are you can go down to Buckeye in Columbus. Where else?
Around here?
Yeah, you can go to Terry's. If she's
too low fire.
Yeah, I know. Terry's low fire. Dude, I told you we'd get her in this.
Well, what are your top two? Like, what would be your favorite? Like, what's your number one? What's your number two?
The number one's the place in Sylvania now.
Cornell.
Dayton. Cornell and Dayton. Yeah, you can go there. But that's an awful long drive. It's easier to have it shipped.
Okay. Yeah, I've looked into things like the big ceramic store and like Clay King and that sort of thing, and the shipping is just like god awful.
Well, we were at Clay King 2 weeks ago, 3 weeks ago.
Yeah.
We were actually coming up through. We were in South Carolina, and so we stopped by Clay King, and Sylvie orders from there frequently. But shipping will kill you.
Yeah, it's half the price of it's just as much as what you're paying for the.
Yeah. The other nice thing is though, if you're looking for heavier things, like you're looking for clay or something like that,
right?
You can. I can always let you know when we're going out to Sylvania, and I can bring it to downtown. Think about that.
I'll think about it. So when I have a similar sort of setup. So like I have like the potter's wheel and stuff in the basement, but like my kilns, I put them out in a metal shed in our backyard. And I dug a trench and ran electricity, and I have a sub panel out there. And so all of the things that could catch my house on fire are in the shed.
Good man.
Yeah, right.
Yep.
But like in the process of digging that trench, Ohio has a lot of clay in the soil.
Yeah, no.
I was digging it. I'm just like digging up just like wads of pure clay. And I'm like, well, I'm going to keep this. So I've been refining it. I have like 5 giant, like 55-gallon bins of clay in my backyard. And I've been like drying it out, crushing it, slaking it, getting rid of all the impurities and sand and and I've been using that, and it's a lot of fun. It's been good because I am still kind of new to this process, and so I'm learning on stuff that's basically free, Yep.
So that you won't want to try and high fire it.
Yeah. I've gotten it up to cone 6. I've gotten it up to cone 6, and it's fine.
Oh, cone 6 or cone 06?
Cone 6, not 06.
The clay outside?
The clay outside? Wow.
Yeah.
It didn't melt?
I'm surprised it didn't sag on you.
I did a bunch of tests, and it's getting up to cone 6 fine. I haven't tried to go higher than that.
Yeah, I wouldn't try to go any higher than that with it. You got lucky there. But see, that's Ohio is clay, man. Our backyard's full of it.
It's a bunch of just red clay, So I don't know.
Well, that's good. I mean, that's so we've actually talked about doing that.
I mean, it's been interesting because like I've been trying to use like normal glazes on it, and they all come out like brown and weird, and like it's not or like clear. And I've tried raku glazes, and no matter what raku glaze I use, it's always like the same copper color. So I think that there's like a lot of silica or iron or something that's messing.
Have a lot of iron in it. Yeah.
Yeah.
You've got something that's reacting with it.
Yeah.
Also, another thing, especially if you're using raku glazes, make sure you're in a reducing atmosphere.
Yeah, I've been plunging it in like a garbage can full of leaves and stuff and closing it off.
The other thing is you check the temperatures on your glazes. You could be overfiring them if they're washing out and going clear.
Well, they're cone 5 glazes. I've been firing them to cone 6 because I was getting pinholing at cone 5, which what I've read online is that's organics in the clay burning off.
That's right.
Gassing off. And so by going to cone 6.
Did you bisque fire before you go to cone 6?
I did.
Okay. Because that a lot of times, if you don't let it soak long enough in a bisque, you'll still have organics burning off.
Right.
And when you get past cone 04, which is a bisque fire, then you're starting to do reactions of other materials in the clay body. By cone 04, you should have burned off all the organics.
Okay.
Maybe
I'm not low or bisque firing long enough.
Could be.
I mean, like I'm using my little Bartlett 3-key controller, just like being like, well, I think this is a good firing schedule. It's getting up to the temperature and it's holding it, right?
Up the temperature and hold it for an hour.
Yeah. Maybe I need to get those cones to test to make sure I'm actually hitting the temperature.
Where you fired at.
Yeah, I mean, but all this stuff would be really great if I had like a log to see like, well, what did I actually get to?
Well, I think you just wrote a piece of software that just.
Well, that's what I'm saying. Like, one of the things that I've been thinking about is just like. With those ceramic cones and like you're saying, like you're not able to know when you hit that temperature. Like, is there some way that like I know there's the bars where you put it in and the lever holds up and like it gets to a certain point and it drops. I'm wondering if there's like some sort of way that you could like take an Arduino or a microcontroller and like listen for that drop. Like you leave the bar in there. And you just use that as like a flag of like, yeah, I hit the temperature,
Well, at that point, you can actually put a switch on it, a limit switch.
Right.
Okay. But that's temperature over time.
Right.
So, I can be cool and extend the time and still meet the heat work. Or I can be hot and shorten the time and meet the heat work.
Yeah, it's like cooking a steak. It's just a piece of ceramic, you know?
Yep. So the biggest thing is, like, if you wanted to know when you hit temperature, the best way to do it is with a thermocouple and an electronic logger.
Okay.
Okay.
That's just hitting the temperature, though, not necessarily hitting the cone. Yeah.
Right. And then you'd have to watch for when the sitter drops out. Then you met heat work, but you can watch it because even in a manually fired kiln, because it's ramp controlled, or all it is basically a ramp rate. I hit a temperature here where the heat work starts, but the kiln keeps kicking on. So the kiln temperature keeps increasing over the time until that sitter kicks out.
Right.
So it keeps doing that. It keeps going up. So it's not really a temperature that you hit.
Right.
It's the work happens because you've reached a minimum temperature, which that cone will start to give.
Yeah. Yeah. You're just defining the rate. And then once you hit it, it stops.
Yeah. So this is where the software controllers have an advantage. You can take it to a specific temperature,
right,
and hold it for a specific amount of time. And if you still used a sitter, you'd know you didn't exceed the temperature. You were always at that temperature. If you use the sitter to say, okay, guess what? Sitter's gone. I've reached my length of time for soaking.
Right.
Isn't that what I had programmed? And you can compare them and say, okay, yeah, it's good to shut off, or no, I want to hold for a little longer because that's what they told me to do.
Yeah.
And then there's these things. There's special glazes that are called crystal glazes.
Yeah, I want to play with those. Okay. I haven't. Have you?
So with a manual controller, it's a lot more difficult because you've got to manually control the cooling rate.
Yeah, it's like a slow cool, right?
You have to come down to a certain temperature and hold at a degrees per minute or per hour, a certain number of degrees per hour, and then you hold at this temperature for a period of time. Then you drop off X number of degrees per hour, and then from there you go down through another cooling cycle. Where with the electronic ones, it's easy. It's much easier.
Yeah.
We can program that. We can tell it, this is what you do.
Yeah. So one of the things that I want to do with PyKiln is like have like a preset library, or have like the ability to import like preset libraries for different types of things. So like if you're doing glass work, or if you're doing, have like the standard like cone firing schedules sort of thing built in, like a fast, a slow, a medium. But that's actually something that would be cool, is to have like, the microcrystal firing schedule already built for you.
We're going to do the firing schedule on the backside, the cool firing.
Right.
So I had started out, like I initially said, I started out working with a Beagle Bone Black.
Yeah.
And, it just life kind of got in the way.
I mean, it's a big thing to bite off. And like, what angle did you go at? Like, what were you trying to do with this thing?
So my whole goal is basically what you've done with PyKiln.
Right.
Is for somebody to be able to sit here in the living room, or be in Hawaii for that matter, and fire the kiln and do it safely and watch it.
Yeah.
And have it be, she can control it like she was sitting here. Yes, we can have controls on the kiln itself. So if you just want to walk up to the kiln and control it, no problem. But the best thing would be logging and control and scheduling through a web interface.
Yeah.
You can do your standard. You'd say we need to fire a cone 6 load. She can walk up to the controller, hit the touch screen, fire a cone 6 regular schedule, no problem. If she wanted to do a special one, if she pre-programmed it, she could walk in there and pull it up and schedule it and fire it. But we all know entering that stuff through a touchpad or
the 3-key controller.
Well, that's insanity.
It's insane. Yeah.
I mean, I've got some little PIDs. I got push buttons for those just to go to temperature.
Right.
And that's still not fun.
Yeah. Yeah. A lot of people have been asking for like an LCD and then like little buttons. And it's like, I keep on having to be like, okay, well, where do you draw the line? Because then if you add all the buttons and controls to the front of the kiln, then it's like, well, then why are you even using your phone? You know?
Huh?
And there are certain things that like I'm building into PyKiln where like it has a speaker and it actually plays little like tunes and stuff when there's like when it's starting and finishes and when there's an error and all that. And there's like an LED that lights up that does like different things based on if there's an error.
I think I found the most irritating warble.
Yeah.
2200 to 2000 kilohertz.
Okay.
Okay. Switch between those every second.
Oh God.
I've got it on a pump controller that I did with an Arduino.
Okay.
For a water well. I think I got the most annoying sound
like
you could
terrible have. Siren.
Yeah, it's bad.
It was kind of fun when I was programming that part. I was like, it's just a square wave, and so I went to like a little like keyboard website that I could like play out a little tune, and I was like, okay, here's the frequencies that I need to hit, and then I just plug them in. I made like a little function so I could just type in like what notes I want to hit. And it's kind of fun. I was looking at that and I was looking at just like a regular buzzer, and like the regular buzzer was like a little bit more expensive and you can only make one sound out of it. And
yeah, I mean, you know, a little piezo speaker is really good. It'll do a lot of things.
Yeah. So you never finished your BeagleBone black kiln?
No.
How are you planning on like wiring it up, and like what was your
So
did you even get that far?
I already had the thermocouple interface, the breakout. In fact, it's the same one. I had a 4-channel one, which is still sitting upstairs. I'm going to use it on this project.
Which module was it?
The 356. 356
okay.
Number?
The Max 31856?
Yeah, 31856. That's right.
Yeah.
Because
I have a video on that one. Did you see I bought like a Chinese version. I did a teardown of it because it was like totally like fake. I ended up so I bought a real chip off DigiKey and I did like a series of tests. Mm-hmm. So I did like an Adafruit module, which is like legit. And then I did like the Chinese module, which was like way off. It was saying it was like negative like 30 degrees Celsius at room temperature. And then I did another one where I swapped out the chip on the Chinese module for the DigiKey chip. And then it was like the same as the Adafruit module. But yeah, I ended up like reporting the eBay seller to the company that makes the chip.
We're selling counterfeits. We're selling counterfeits.
Yeah. And they're like, our legal team is all over this. Thanks for doing like the research.
So I've got to. I'm gonna show you a couple things.
Okay.
So.
Oh man, you went like full tilt on that.
Well, it even gets even a little better than that because around the outside are LED strip lights. In red, green, blue, and white.
Yeah, the NeoPixels, the W whatevers.
Yeah. No, not the NeoPixels.
No.
These are not addressable.
Oh, okay.
There you can see the OLED display, maybe.
Yep.
You remember where the camera's at?
Yeah.
Okay.
Does that have, is that connected to Wi-Fi?
Yes, it is.
All right. Okay. Yeah, I see where this is going.
That's an ESP32.
Yeah.
So, there over here on the side, there's the light sensor. Mm-hmm. And this is the same on both sides. That's 96 8x8 segments.
Jeez.
73 Max 7318s. Oh, by the way, they're Chinese knockoffs. It took an extra 2,000 lines of code to correct that.
Ugh.
But it took me a while to figure out that they were Chinese knockoffs, and I started having glitches.
Yeah, I mean, the thing is you get what you pay for. Like
you do, but you figure $3 a piece versus $12 a piece, and 96 of them.
Yeah.
Yeah.
That's what, like, when I was looking at the Max 31856 chips, the chip itself is like $6. And it's an amazing chip. It does a lot of great things. It works with like every thermocouple there is.
Yes.
But yeah, so that's why I found those Chinese modules that were like $10 a piece. And I was like, this is great. Versus like an Adafruit one, which is like $25. And I was just like, I don't want to spend like $100 on like a 4-zone, kiln. But you know what? Because of all that, I learned a lot about the chips, and like I feel like I'm using them. So like in the circuit board that I'm designing, I have one built in. So that's savings, because no matter what kiln you have, you're gonna have at least one. And then I have support to add another 3, so you can have more zones to the kiln, and you can buy the Adafruit ones. I'm also planning on I'm planning on selling like a pre-made kit. Like it's all going to be open hardware too. So you can send it off to a fab and populate it yourself if you want. But like I'm making my own modules as well that are basically the same sort of thing as the Adafruit ones. I'm doing something a little bit different. I've been playing around with actually HDMI cables, but to decouple. So like you have the ESP32, like power and stuff going to it, but like all the breakouts for all of the elements and the sensors and that sort of thing, I want to have at the kiln itself. So if you want to put like the ESP32 on the wall and then just have, yeah, exactly. So I was playing around with Ethernet first. That was my first one, but I wanted
controller back.
Yeah, I wanted to have more pins than that. So I was playing around with HDMI cables, which also HDMI cables are not all created equally.
They are not.
The spec for it is insane. Like I have a cable that is missing like 8 wires in it, and like other cables that have like, they're only missing like 1 or 2, but like there's like the CEC cable. So like certain HDMI cables can do like 8K, and like some of them can do like Ethernet over it, and some of them can do like you send commands through HDMI to turn your TV on and off and that sort of thing. So they're all very different. They're all called HDMI, but they're all different. Which made it
spec on them, and you got to see if they're capable of Ethernet too, because they also pass Ethernet.
Yep. So I think I'm actually going to abandon that and go back to just using, like Cat 5, Cat 6 cable, just because I need to do some testings on this to confirm. But like with thermocouples, the way that they work is they're just 2 different metals, and it's detecting that voltage difference. And the issue is if you use a HDMI cable, it's copper, and so then it doesn't I don't know. I'm not a complete expert on this, but like it messes with the voltage. And so,
that's right. Well, not only that, but it also, so thermocouples work by a reference temperature too, a junction reference temperature in the chip. That's why you have to that's why the wires are very specific. K wire for K-type thermocouples. It has to be that all the way back to the junction.
Yep. So I'm probably going to go back to Ethernet, just because that cable needs, if you were to separate the controller away from like the breakout and the relays and that sort of thing, you'd want that same type of cable the entire way through so that your temperature readings are accurate. So anyway, fun tangent.
I'll see, as far as I'm concerned, the thermocouple breakout has to be at the kiln. Yeah. You're sending data back. Now, I have found this, just a little FYI. I have run successfully I2C from this is from an 8266, okay, an ESP 8266. I've run an I2C over 6 foot of an audio cable. 1/8 inch mini stereo. I've run that 6 foot successfully, no problem. It's not a shielded cable. It's not a super shielded cable. It's a just traditional truck stop audio cable.
Right. That's
I
an
wouldn't
interesting
try-
idea. What if
I wouldn't try to push
the
it much
breakout?
further than that.
Sorry, what was that?
I said I wouldn't try to push it much further than that.
Yeah. I mean, what if the breakout was on the breakout board itself and it wasn't just like a junction terminal? Like, what if it had like I don't know if there's any, there probably are thermocouple sensors that use I2C, and then you could just talk to them.
There are, well, see,
And
it's
then
it's about the same as SPI as far as distance capabilities. SPI, you got to make sure you put in your terminating resistors.
Yeah.
If you're doing anything more than just a couple inches or a foot or so.
Yeah. The Max 31856 is SPI, which
her sign, it took me because I was lazy and didn't want to drive to the other side of the state and pick up my O-scope, which is 2.5 hours away. So I had problems with her sign after about 30 segments because it's regenerative signal, but the clock and chip select are not. Okay.
What do you mean by that?
So your clock has to stay clocked off your master.
Yep.
Oh, not allowed. We're not supposed to use that word anymore. Whatever they call it now. Okay. So all the chips are slaved off that in a bus.
Yep.
Well, because of propagation of delay, the time it takes a signal to get from point A to point B on a wire, and obviously smaller wire adds resistance, you get signal degradation. So instead of having a clock signal that looks like a nice square wave, you end up with this thing that kind of looks about like this.
Yeah, I mean that's more capacitance than it is.
Well, you have capacitance, but you also have to have a loading resistor at the end. Okay, to actually cause it to produce a cleaner signal. So you've got capacitance, resistance, and distance that you all need to take it. So if you were going, let me show you if you were going from controls down in here, over this door, down the wall to the kiln, that's a long distance to be moving a signal.
Right.
So some of it has to be at the kiln, some of it could be up here. And this room gets really warm. It's right now it's got some other stuff in it because we weren't firing in the past 2 weeks. But as I was saying, so this is the bigger of the oops. Okay. Where is it getting? This is the bigger of the two kilns.
Looks nice.
Yep.
Did you get
And
that?
there you can see the remnants of a bar.
Yep.
And this is an even heat kiln. And this sets your ramp rate and your and the power control. When you first turn it on, it gives a number of flashes. And you set this to 0 for set. And you move it up till it flashes where you want it. This is the timer.
So that's the timer is when it hits the temperature?
The timer is just that. It's just an hour timer.
Oh,
Right
so
here.
it's when it starts? So it's a delay?
You normally set it for if you want it to fire for 8 hours, which is say a normal cone 6 firing, you set this to 10. If it hits 10, it kicks the kiln off. It's a safety.
I see.
Okay.
Cut off. Yeah.
This is the part for the sitter.
Yep.
Okay.
And that lifts the lever. Yep.
Yep.
And then you just put your ceramic bar in there and holds it all together. And then when it melts, that flips down.
That's correct. Now that's the even heat. The little crest is a little different.
Mm-hmm.
You turn this to start your starting power. Down here is your speed timer and sitter. And it's the same, but it's cute inside. It's dinky.
Yeah. So, how did you guys come to, like, is it just a lot of trial and error? Like, how did you figure out, like, what works well with the clay that you use, or with
the clay we buy.
What's that?
Has so she buys the clay pre-mixed. We do not have a pug.
Yeah.
Okay. So she buys it pre-mixed. It's already in blocks, in 25-pound blocks. And we know it's a cone 6 capable clay or a cone 10 capable clay, or it's a low fire ceramic clay. So it fully matures at cone 04.
Mm-hmm.
So there wasn't a whole lot of trial and error in that. The biggest thing was making sure the kilns fire properly.
Yeah.
And that's no problem. I mean, I've got that down to science, but I still hate having to mess with them. And when she comes to me and says, kiln under fired, like, oh man, now I gotta go mess with the sitter again.
Right.
Get it adjusted.
Yeah.
And it's a lot of fiddling. And then we have to do test fires. And, that's just like the big kiln. Both those two kilns, I'm considering them set up for 3 zones.
Mm-hmm.
The elements are grouped in 3s automatically, or already. So it automatically lends itself to 3 zones. I might have a couple thermocouples sitting around.
Oh. That's pretty long.
A little long.
How much how much fire brick are you going through on that one?
Yeah, that one's just a little long, but it was available.
Yeah.
I also have. So I'm a blacksmith. So my shop, I've got gas. These 2 pieces that I trimmed off this other thermocouple would make a really nice other short thermocouple for another small kiln.
I've never thought about welding your own thermocouple, but
so
why not?
Wire, and all they do is they gas weld. You don't electric arc weld them. It introduces a lot of impurities, but you gas weld these together at the end, and that's what makes the junction.
What do you know? What metals they're made out of?
One's a chromium, one's an aluminum, one's an iron, and one's a chromium. Okay.
I mean, iron, that would be a really high temperature. Can you get that with like MAP gas or something, or would you need like oxygen acetylene?
Oh, actually acetylene.
Yeah.
Yeah, you could possibly get it, but I don't know with the MAP gas. Possible. I mean, yeah, that's probably possible.
Yeah.
Depends on, how much you've got available, and it's the oxygen that really makes the gas effective.
Yeah, I have a backyard foundry where I do like in college. I went to art school and I minored in sculpture and did like bronze and aluminum casting. So I have a small backyard foundry that it's just like a big steel bucket lined with kale wool and propane tank with a forced air
forced air burner.
Yep.
A ribbon burner.
Real simple. Yeah. It works. I can get up to temperature and cast things. I've been playing around with like sand casting lately.
That's fun.
Yeah, it's fun. I just got I splurged and I got some silica slurry, like a 5-gallon bucket. It's like it's not Suspenda slurry. It's another brand. I got it from Remit. But I want to get back into like ceramic shell, like gloss wax casting and that sort of thing. So
here's one of the baby kilns. This is the one I put a PID on.
Yeah.
And there was the control for it.
Yeah, screw that.
Basically an oven controller.
Right.
This one, the inside needs some work.
Yeah.
The bottom had been
abused a bit, but that's okay. That's going to come out and get a shelf put in it. So
Yeah, and that's a nice little tester kiln. You could throw a mug or two in there, and
Well, and we just did gold firing on it. In fact, I'll show you the piece that she did. Oh no, I won't. She shipped it. Okay.
gold firing, like actual gold, or
Yeah, like gold. I'll show you a piece that has been done. Here's another one. You can see the control down there, low, medium, high.
yeah.
This one I did take and put a pyrometer on it. But the inside of this one's a lot better.
Yeah.
You can see the floor of it's really, it needs washed again, but
Cool. So have you, I know that you're interested in like beta testing PyKiln, playing around with it. Have you played around with MicroPython at all?
so it says the word Python, right?
Yeah. I mean, it's Python. It's just on a microcontroller is basically it.
That's her studio part.
That's fun.
Okay. These are all full of glazes that look like that.
Have you tried making your own glazes?
Oh yeah, we do some.
Yeah.
More glazes.
I bought some chemicals a while ago, but I haven't tried to mix anything up yet. Any recommendations of things to start with? I've heard you're supposed to start with clear.
Yeah, clear's good. So I'll tell you another. I'll tell you what I found. Unless you're going for something that you cannot purchase pre-mixed,
Yeah.
or unless you're going for large volumes, so you're dipping. If you're just going for decorative glaze, buy it pre-mixed.
Yeah.
Best recommendation I can make you. I make my own slip for slip casting.
Yep.
But I always start with a box of pre-made slip, and I've got a hydrometer.
Yeah.
I've got a scale. I check my specific gravity all the time. I use sodium silicate. I don't use the what do they call it? Anyhow, I use silicate for my she's a pizza. Anyhow, flocculent. Thank you.
Yeah, that's the word.
Okay. So you can overshoot the silicate and gel up your slip easy.
Mm-hmm.
So you got to watch it. But glazes are basically almost a clay body.
Yeah.
That has more silicate in it than anything else. But
It's a glass former, a flux, and a clay body, right?
Yep.
Those are the three things that are in a glaze. And pigments.
all that stuff under there. All that stuff under there. If I'm see that when I'm showing it to you, but that's all slip back in here.
Yeah. So you buy your slip already pre-mixed. You don't try and like make your own slip.
No, I do make my own slip. But I always start with a box of pre-made. It allows me to add to it and adjust easier. So I use. How long is this? I'm trying to not get you to get the lights in your eyes and yet still have a.
Yeah.
Here, we'll try over here. Anyhow, I use 2 gallons of slip in a 5-gallon bucket, and then I add clay that I've slaked.
Mm-hmm.
And I add that another 2 gallons of it, so the bucket's most of the way full, and then I'll go in and add the flocculant or the silicate until it's the right water runniness and the right specific gravity.
So what? Okay, so you have the slip in the bucket. You add more clay to it, and then you add sodium silicate to it, or you add water and sodium silicate?
Water and sodium silicate. And the trick is to not add too much of either one.
Yeah.
You have to get just right.
So I guess why would you start with the the premix to begin with?
Because it gives me a base. I can add I can add it in portions and keep my balance of silicate or flocculant and water proper.
Mm-hmm.
Okay. Because I'm not doing
What are you measuring to see if it's proper or not?
You know, so there's two things you measure: specific gravity.
Yep.
Okay. You want to be above 1.7.
Mm-hmm.
The closer you get to 1.9, the better to an extent. I've found 1.73 is about my perfect for what I'm pouring.
Okay.
But anything above 1.7 is good. There's people that'll try for 1.8 and you can, I've tried to work it out. It's very inconsistent getting it there. Because we also don't have a big mixing station where it can agitate for 20 hours and okay.
Yeah, how are you mixing it and keeping it consistent and like?
I use a drill
mm-hmm.
and a drywall
paddle. Yeah,
paddle. And then to get it started though, when it's very clay-esque, I use a paint mixer.
Okay.
On a drill. But what I do is I can dip the end of that paint mixer and I use that for my testing to know when it's fluid enough.
Mm-hmm.
I put it in there and I just watch for how it runs off the end of it and how it webs across or how it skins across the end.
Mm-hmm.
And it should run just about like water.
So I guess you add the water and then how do you know how much silicate to add?
I do it by sight.
Okay. So it's not an exact science.
There is an exact science to it.
Yeah.
But I'm not starting with dry ingredients.
I see.
Okay. I'm starting with unknown quantities of ingredients.
Yeah. So I guess you have the slip, you add the clay, you add the water, you mix it all up, you get to the specific gravity that you want. And then you add the silicate.
I won't be able to check specific gravity first because it'll be too thick.
Yeah.
I mean, it'll be thicker than sour cream.
Mm-hmm.
Then I start adding little bits, and I added a little. Well, so to start with, I added a little more than drop wise. I added because I'm doing a 5-gallon pail.
Yeah.
I'll take a little pour out of a small container to get it to about where I think I'm getting close. And then at that point, because then it's starting to get fluid, then I can start checking specific gravity. Now, if my specific gravity's off, if it's too low, I know I've got too much water. I need to add clay. Okay. If I add clay and it gets clumpy, I know I don't have enough silicate.
I see. So the silicate helps to break up any clumps of clay.
It keeps it fluid. When it gets clumpy and thick, heavy, more like a really thick mud pie, then I know I don't have enough silicate. Now, there is a point in time where if I add more silicate, it'll start going the wrong way. It turns like Jell-O.
Yeah.
There is a way to recover from that, but it's not. There's two ways to recover from that. The first is take your bucket, put it half in another bucket.
Yeah.
Add more clay and add more water. Okay.
Yeah.
Reduce the amount of silicate percentage overall. The other way is vinegar. You can deflocculate it using vinegar.
An acid?
Yep.
How does that work?
I didn't check all the science behind it. I should have. I can't really answer that one.
Yeah.
But it does work. I was in a bad way one day. This is quite a few years ago, where I didn't have anything else to start with or to work with or any free buckets, and I needed to pour slip that night. And so I got online and I started Google searching. How can I undo? Well, guess what? Vinegar, and it did work. It worked fine. It has to do with how the vinegar, the acid, releases the flocculant from the clay molecules.
Huh.
Okay.
So
I mean,
it's like fighting the silicate, and so then
it's fighting the bonds.
yeah,
Okay.
yeah,
That's causing the abundance of silicate to clump up with the clay molecules. So I went and found that does work.
okay, good to know.
But
I haven't tried slip casting yet, but I've tried to make a few slip molds, but like I haven't bought pre-made slip before. I was just like, here's some watered down clay, maybe it'll do something, but
It will, but it'll have too much water.
Yeah.
So the problem is if you can get clay wet enough to pour without using any flocculant,
yeah,
it'll pour, but when it dries, it shrinks so bad,
yeah,
depending on your mold. So if I were doing an open cast mold or a void cast mold where it's just a mold around the outside.
yeah. What I tried was just like a small bowl. So it was,
Yeah,
it was something that had plenty of draft, like it could fall out, no problem. But I don't know. I didn't try too hard. I did it like once and I kind of gave up after that.
A mold that looks like that,
Yeah.
you don't care about shrinkage on if you don't have anything that's on the second half of the mold.
There's no undercut. There's plenty of draft. It's not going to hang up on anything.
So, come on. He's smarter than the mold, you moron. But when you're talking a mold that's a plate or a bowl where you have both sides of it, okay, it's really important that you reduce shrinkage as much as possible. But then you also have to separate the mold early enough where the clay is still plastic.
Yeah.
Because otherwise, in that mold, it'll rip the lips or undercut or edge off that bowl or plate and cause cracking and separations, and it'll fail.
So how long for, at least I know that everything's going to be different based on what clay you're using and what mold you're using, but like typically how long do you leave the slip in there before and I know the longer you leave it, the thicker it gets and all that, but like how long is a typical slip cast for you?
So that little bowl I showed you,
Yeah.
okay, it stays in there. The void is full of clay, 3 hours.
Okay.
Okay.
What sort of material is that? Is that just like pottery plaster or what is it?
That is, well, that's potter's plaster. It's a casting plaster. Okay. It's made specifically for molds.
Yeah.
The slip is just made from her tailings. Okay. So it's going to be a stoneware cone 6 clay that we mix in. And so for plates, there's a spot when the plate molds are both sides and there's a hole in the back, like this, that you fill it from.
Okay.
That in metal casting, that'd be your sprue.
Yep.
Okay.
You're talking my language.
We definitely got to meet.
Yeah.
My cousin has a machine shop. I was a machinist. I actually was a professional machinist too.
Cool.
I practiced that trade for a year. I've done a lot of things, so I have a lot of fun. If you don't have multiple hobbies, I mean, what looks good fun? So, but in this, that is what we call the spare. Okay.
Okay.
It's the sprue, but it's also the spare. And after it's been in the mold for enough time, you pour the spare out so you don't have to dry that clay, because all that moisture has to go into your mold. Okay.
Right.
If I have to pour 2 plates and I don't have 2 molds, that means I have to re-pour that same mold afterwards. Now that mold's got moisture in it.
Yep.
How much moisture can that mold hold? Okay. So now I have multiple molds for the plates that we use. They were based off one of Sylvie's hand thrown. Okay. The bowls too. So we got 3 different plates, a bowl. That little bowl mold I showed you is not. That was just one we picked up free. So I've got multiple molds, and I had these made. Now I'm going to go through and I'm going to actually cast the molds. I got one that set that's starting to get worn out.
Yeah.
Loaded up with silicates through the plaster. It's no longer drying or drawing the moisture out of the clay quick enough.
Oh, like the mold over time gets.
They wear out. They literally wear out.
Huh?
Because you load the clay or the plaster up with silicates and other particles from the water.
Mm-hmm.
So it's loaded up with salts. It'll no longer draw water out.
And there's no way to remove that.
No.
Is there? Yeah.
No, not really. Not without destroying the plaster that it's made out of.
Right.
So I got a couple molds that are starting to go by the wayside. And so what I'm going to do, Smooth On makes some really good poly pouring kits. I'm going to pour a mold of the molds, and then I can make molds from my pours.
Yep.
Yeah,
My attempted slip cast molds, I 3D printed the master, and then I made a plaster mold around that.
That was great.
Yeah. I think I just use like Home Depot plaster, which probably isn't the right stuff. I just watered down my clay to make a slip, and I didn't measure the specific gravity or anything. So I'm sure I did it completely wrong.
So yeah, the clay, the slip that you pour with, you need the silicate in it. You need to keep the amount of water as minimal as possible to get a fluidity that's equal to water.
Right.
You want to pour like water, but you don't want it to be that much water in it.
Which is where the sodium silicate comes in to act as a flocculant.
Yep.
To make it more like water, but still keep the specific gravity
high. Yeah. Yeah, because you want it to be as close to 2 times the amount of 2 times the weight of water that you could possibly get.
Okay.
Oh, wow.
That's a hell of a gallery.
Oh yeah, there's a gallery here. So I'm just gonna walk you past it. This is just the outside.
That first wall is like more pots than I've made in my entire life. I don't know.
we have some fairy stuff.
Yeah.
Then she has this is the center. Then we have mugs and whatever's displaying, and we have some wire wrap jewelry.
Cool.
And those are mostly incense burners and tea light places and crystal items with crystals on them.
Yeah.
So
how long have you guys been doing pottery?
She's been doing pottery since 2006.
Okay.
I've been doing it since 2011.
I've been fixing buttons.
I've been fixing. Okay, so I am the technical side.
Right.
I am not an artist. I don't claim to be an artist in that way. I can be an artist when it comes to writing code, and we're gonna get back to MicroPython in a moment.
Okay. We went off on a tangent.
But she's the artist when it comes to doing pottery. But, along with doing pottery, sometimes things go wrong.
Yeah. There's a lot of science behind it. It's crazy.
And despite the science part, okay, so when the kiln misfires or when something's wrong with the glaze, yes, consult with me and we would talk about it. We work things out, or I adjust the kilns. And so a lot of times we contact the glaze the glaze manufacturer and say, hey, guess what? These are the results we had. Why did this not come out right? Because you had to have known what happened. Sometimes they do and sometimes they don't.
Okay.
But a lot of times a piece of pottery just comes out wrong. Broken, cracked.
Right.
Something else. Well, then she says, oh, I'm just going to throw it over here. No, let me think about that for about 10, 15 minutes. I'll come up with an idea. Or just let it sit on the shelf for a few days. I'll think about it. And we usually come up with something to do with it. And then it's got a story behind it. You know, those pieces sell first. Every time. So my artistic material, if it's electronic, if it's mechanical,
right.
If it's broken, it's mine. I also love to do ornamental ironwork. That's mine.
Oh, yeah.
So we're going to actually combine the two. But I had to get a floor in my building, which it got the floor last fall. Now I had to just finish the lights. I just got insulation in for the ceiling.
Yep.
But we had to put all the stuff back in it, so now I got to work around my stuff again. But at least it's up on the floor. It was a dirt floor in there, and I've had that in it. We've lived here since 2013, so it's been it was 7 years that I had a dirt floor in my building, and you couldn't put up any shelves because it kept falling over. The dirt would give over winter. Yeah. There's moisture in it. You may not see it, but there's moisture and it moves.
Yeah. So, when I was like running electricity out to the shed, because the soil is so moist and like clay, like you have to go real deep. It's ridiculous. Yep. Like I was telling my dad, I'm originally from Maine, and my dad was saying like it was like 18 inches or something in Maine. I did 3 feet, which is
you want to get down below frost line.
Yeah.
But so you have to be 18 inches in your 24 under drive, and you should be a conduit.
I did the direct burial cable. It's got like that thick gray coating on it,
yep.
So it can just be.
Yeah, you used USE or US cable.
I'm trying to remember. It's
direct burial. It's gray.
Yeah. It was real thick and a pain to use. I probably should have just gone with conduit.
Well, you won't go wrong with that. It's good cable.
Yeah.
So for her, well, when I did this building, I also put a new service on the inside of the house. Mm-hmm. It's direct burial cable, but I had to run 4 conductors because I'm a sub panel. Mm-hmm. Okay. And then, so we go from the house to here, outside. It comes right off the meter. I've got a distribution panel right under the meter. Comes to here, and then from here it goes back to my building. So Sylvia and I are sharing a service. But that's not a problem. We've got more than enough power to handle it. But she shouldn't be firing both kilns, and me trying to run a kiln or anything in the back at the same time. It just wouldn't start.
We have to budget stuff like that too. I'm like, you don't get to run like the dryer or like the vacuum while I'm like doing stuff.
So, but back at MicroPython, it says Python. So early on, many years ago, I had to choose a camp between Perl or Python. Mm-hmm. Okay, so here's the rule of thumb. In Python, there is one way to do it. There is only one way to do it. And don't you dare think there's another way to do it. We're not going to let you.
Right.
In Perl, there's 1,000 ways to do it.
Yeah.
Oh, you don't like any of our 1,000 ways? Well, feel free to create your 1,001 or 1,002. Just give it to us. Everybody else can use it. So I went the Perl path. Now, C++, and a bunch of very old languages. You want Fortran? You want COBOL? I got them. There was a thing called Pascal. I know Pascal pretty well too. You know as well as I do. Programming is programming is programming. If you know the one language, do another, and I have done some Python programming. It's not my strong suit, but it's not a super weak suit either. Just I do a little more referencing when I'm doing.
Yeah.
As far as with the microcontrollers, I've been using C++. It's easy.
Are you using the Arduino IDE, or are you doing like?
Well, so I use the Arduino IDE to upload. I program in Komodo. Active States Komodo IDE.
Okay.
Okay. That's my IDE of choice. But I do upload through the Arduino IDE. It's easy.
Yeah. The one thing that I really like about MicroPython versus like I've programmed Arduinos in the past and done like I have done a lot of like C# programming in the past and that sort of thing. And honestly, like Python has not been my favorite like go-to language when it comes to like, you know, writing efficient code and all that sort of thing. But I find that, you know, MicroPython is really friendly. And, you know, because like I've done a lot of stuff with programming with Arduinos, it's just like, oh, you have to reinvent the wheel like every single time. And like, it's just like with Python, like, oh yeah, it understands JSON data, no problem. Like, yeah, it's fine. Don't worry about it. Like, just keep programming. And like with like microcontrollers, especially like the ESP32 and like moving to like ARM chips and that sort of thing, like you're just getting so much processing power that like you don't need that level of efficiency that you know could get out of programming in C.
Right.
And so with that too also comes like better debugging tools because it's running you know in real time on the chip. It can tell you, hey, that line of code, there's the problem, versus like on an Arduino, it's like, well, I'm just going to write a bunch of print statements and hopefully like I'll find something. Like,
you know, hey, where did it stop? Where did it fail? Oh, here's my print output. Okay, it fails right after that before the next one. Got it.
Exactly.
Yeah.
So I've really enjoyed working in MicroPython, and I feel like it's going to be the future, like everything. Well, I'm sure there's going to be, everything's going to exist forever, but like, I think that things are going to trend towards MicroPython, and with like selecting that, like with using that, I think like I'm setting myself up for success for the future. I know that it's not super popular right now, and there's not a lot of libraries that like, you know, you use the Arduino like IDE and you get a million libraries for every sensor that you could ever want. You don't get that necessarily. What's that?
Sometimes that's a problem. Which one do you want? Oh, and by the way, did the developer decide to just abandon it?
Right. And sometimes though, like you don't even know, like sometimes they implement things that aren't in an efficient way where they're using like software, like in bit banging the protocol rather than using like a hardware device. That
seen it 1,000 times.
So you know, I think that like MicroPython is the best solution for PyKiln. Also with the front end of it, I'm using Vue, which is it's a newer JavaScript framework. I don't know how much like web development you've done or like.
I am not a JavaScript dude, and I'll tell you why. Okay. I can turn it. My clients can turn it off. Yeah. Okay. So I don't write with JavaScript on purpose. I use PHP. I use HTML5.
Yeah.
If I have to, I will include a JavaScript if I can't do it any other way. But chances are I can drop to C, or I can drop to something else as an embedded code and make it work. I haven't found anything that I can't do basically with PHP and HTML5.
Yeah. I mean, the thing is, though, is like PHP is like a back-end scripting
That's
language,
right.
you know?
You have to process on the server.
Right. So
there's
like
gotchas there too. Trust me.
Yes, there are. So the way that I'm kind of doing this is it's not something you see typically, but like what I'm doing is I'm actually using GitHub pages to host the page. And because of that, it has to be a static site, right? So like there's no backend server that's powering this. It's just like, well, here's the file. Like, so because of that, I'm really leveraging the front end. So I'm using as much of the person's device as possible. You know, your phone, your computer, you're doing all the work.
Right,
and I'm just supplying, here's like the shell app. And then all that it's doing, all that the ESP32, all that this thing's doing is this is acting as my back end. So my Internet of Things device has like an API to it. And I'm just sending and getting data off of this. So this is my back end. So like I'm using as much of the front end as I can to make things really responsive and like nice and friendly to use. And being really conservative with the amount of data that I'm sending back and forth.
That ESP32 is really powerful.
Yeah.
Okay. So I have to ask this because it's something that got me early on, and I hadn't been thinking about because there's no operating system per se to handle it on the backside. So running dual cores, if you start writing processes and tell it which core to run on, you have to watch if you're sharing variables or anything like that. So you really need to work on atomic functions or the idea of atomic functions.
Yeah, non-blocking functions and that sort of thing.
Non-blocking, but
so I'm using...
You have to have exclusive variable access. So you can't have this process accessing a variable and this one at the same time and making a modification. So you need to block.
So with MicroPython on the ESP32, they pretty much only let you use one of the cores. So there's one core that's like basically just handling the Wi-Fi, and then the other core you can use for your code. And then with MicroPython, there is support for threading. So you can create multiple threads to have different processes running at the same time. You can also do threaded coroutines where it's like sharing, a thread. But I'm all over that. Yeah, I'm not writing blocking code, that sort of thing. But I know that these things can do a lot. And my first attempt of doing this was actually putting the web page and everything on here. And this was serving up all the files and that sort of thing. The problem, though, is like the amount of files that go into like displaying a web page is actually pretty significant. And it's a lot of space that gets taken up by this thing. Like this has like 4 megabytes of space. I know you could add more space to it if you wanted to. But I really wanted to see like, what can I get away with? What can I cut to make something that is like as tight as possible? Like, that's why I cut like, well, do I need an LCD screen? I don't think I do. Do I need like, what can I do more with less? Like, what's the most that I can get out of this thing? And I don't think that value is serving web pages off of this. Also, so if I do serve web pages off of this, my original idea was like you connect directly to this thing's like this acts as a Wi-Fi access point, and you connect to it, and it's its own offline network and that sort of thing. And that has its benefits, but if you have multiple, then it becomes a pain to manage, right? So if you have 2 kilns and you want to connect to both one, now you have to connect to 2 different Wi-Fi access points if you want to be able to manage it, versus these things being connected to a single network. And one of the things that I thought about with like, okay, well, if the web page isn't hosted on this and it's just being my backend that I'm sending API requests to, if someone is not connected to the internet, how the hell are they supposed to control their kilns? And my plan for that is that GitHub page that's being hosted online, you could still have a page hosted locally within your network and connect to that device. So if you had another computer, like you could have a Raspberry Pi if you wanted hosting that web page, you could connect to that and it would still all work locally within your network.
Yep. I follow where you're going. I like that. That way you have one place to connect to. You control whatever you have.
Right.
And basically,
and you could do both. You could do both. You could still connect to the GitHub page and also connect to the local one, because all this cares about is the API requests that it's getting.
Yep. I like that. I like that a lot.
Yeah.
I like that a whole lot. Hey, no, by the way, for the person who wants to flip and touch screen, okay, it's fine. In there on the wall, you put an ESP32 with a touch screen on it that connects back to the GitHub page.
Yeah, I mean, you could put like a prepaid Android phone like right next to the ESP32 if you really wanted like the touchscreen, you know?
Yeah. Or just take one of your old phones. Don't have service on it.
Yep.
Bluetooth it, or Wi-Fi it. Either way.
Yeah. So, anyway, I'm
gonna go back in the house. It's hot out here. Somebody wasn't lying.
Yeah. So that's kind of what I'm thinking. I'm still working on it. One of the big things that I've kind of come to realize is like a lot of people who are into pottery aren't necessarily like tech people. And
no, they're not.
What I want to do is like make something that anyone could jump up, like could buy, put together. I want to eventually have videos that show like, okay, well, this is how you wire up the elements and that sort of thing. And to load the software onto one of these, originally I was playing around with like, I wrote a command line script. It was just a Python script that was just like, stepped you through each step of the process. I actually have a video on it on YouTube as well. And you would like it would prompt you to plug in the ESP32, and then it would automatically detect the COM port of the device that you just plugged in. And then it would ask you for like the Wi-Fi password and that sort of thing, and would load it onto here. But I feel like command line is still a little bit scary for people. And
it's a lot scary for a lot of people.
Yeah. So I've been playing around with tkinter. It's a Python library to make like a GUI. And so I made like a nice GUI. I haven't like released it yet, but like it's using the same code that I was doing before with the command line, but now there's like an interface to it. And kind of the one thing that's nice about it is like, I have it set up where you can set up a new PyKiln, and it will go through the entire process and like flash all the firmware onto here. You enter in your Wi-Fi SSID and password and that sort of thing, and then it connects. And then one of the tricky things is like, when you connect a device to Wi-Fi, you need to get the IP address of the device. And so I wrote in like a little sequence into it. So like when it connects, it will tell you, and it will automatically open up your web browser using Python to the IP address of the device and tell you, hey, bookmark this. Like, otherwise,
the other solution is that people enter an IP address. So it's static. It's always the same.
I don't know how well that's going to work on
it won't.
Wi-Fi.
Most people don't get it. They don't understand.
I know.
So DHCP is the only way. You just need this.
Right. So the other thing that what I built into that GUI is, so you can set up a new one, which will go through the entire process. And then another button on that, like once you open up the application, another button below the setup is to like set up just the Wi-Fi. So if you already have an existing one, or you changed your Wi-Fi password or name or whatever, but you don't want to delete all of the firing schedules and reflash the entire firmware, you could plug it in and then just change the Wi-Fi credentials on here. And it would go through the same process of opening up your web browser to this device. So I think that's going to be a lot more user-friendly for people than command line.
Yep. Oh yeah. Command line just, if we were back running MS-DOS or the early days of Windows, be no problem.
Yep.
If we finally get everybody over to Linux, it'll also be no problem. But I don't think that we're going to go back, and I don't think that we're going to get everybody on Linux. So
no. and like I want anyone to be able to do this. And so like I'm specifically, it's a challenge for myself. I'm trying to make this like as simple as possible so that you don't have to, I don't want to make people think.
No, yeah. So what we have to do is use technology to make it so anybody can do it. Now, technology doesn't fix stupid. They're still going to have stupid out there, but you can't you can't try to fix that. Trust me, I've tried. It doesn't work.
All right. I'll take your word for it.
It just does not work. So you make it as foolproof as you can, and stupid's still going to happen. But don't worry about them. They'll prune themselves out of the genetic pool soon enough.
I don't know about that, but
well, others will take their place. Don't get me wrong.
Fingers crossed. I don't know. Yeah. I mean, is there anything, I don't know how deep into like how much you've looked into PyKiln and like the videos that I've released, or if you've looked at the code and that sort of thing, but honestly, like what's up there probably won't run. It's not in like a working state right now. But if you watch some of the videos that I released, you can kind of get like an idea of.
Well, I did watch a lot of the videos of what you released, and what I saw, I really, really liked. Where you're going with this was where I intended to go. In a general standpoint, I mean, okay, yeah, you're doing a little more with GitHub and offloading some of the web portion of it to make it more efficient for the ESP32.
Yep.
Okay. I wasn't going to be that efficient with it, but I was also on the backside going to use Fram. Are you familiar with Fram modules?
I haven't used them. It's just additional storage. What is it?
It's RAM. It's a ferromagnetic random access memory.
Okay.
It does not lose storage when you lose power. For 99 years. Wow. That's the rated lifetime of the memory. So you store something in an address. You store a byte in an address. It'll be there 99 years from now, unless you've overwritten.
Yeah.
It does not suffer from flashware.
Yeah.
Okay? So
yeah, I don't know. Do you know how long the flash on this is going to last?
Yeah, that's about 10,000 writes.
Okay. Just minimize the amount of writes to it.
Will still be signed. Well, and you have to remember that certain areas get overwritten a lot more frequently.
Right. Like if I'm logging stuff, that log is going to get thrashed.
Sylvie Fine, which she updates every day. Okay. She changes the message at least twice a day. Well, potentially you could suffer from wear on the flash, where it become unusable. Even though there's some optimization going on within the device itself. I mean, they're not dumb. They actually do flash optimization to an extent.
Right. I'm hoping they probably have that in MicroPython where they just like randomly move it around, so it's not always the same.
I would double check. I wouldn't assume that, but because I felt that with all the writes I had done, with all the stuff that's going on, I could potentially cause it to crash.
Right.
And it's not that I don't have it socketed. I mean, I can go pop one out, reflash it, and have it back in there in a matter of a couple hours.
Yeah.
Okay, but I have to do some tear apart on the sign to get to it. It's
right
because it's weather sealed. So I used the Fram modules, and it gave me 512K. It's I2C bus, and I will tell you, it's really reliable, except I2C bus and that Fram module do not like a 5 kilohertz LED control signal close to it.
Okay.
So it in her sign, it tends to glitch on reads.
Yeah.
So you have to go through and refresh the website a couple times. Make sure you've got what really was supposed to be on that sign.
Yeah.
And I plan on programming that problem out this winter, but I needed to get her sign up.
You should definitely play around with the ESP32 and MicroPython. I know that they also make modules that have the like a micro SD slot on them for storage. And that would probably work too. And then you have plenty of storage.
Yeah. And maybe I'll change over to it. And I didn't think about going to an SSD where I could just pop it out and change it.
Right. The cool thing about MicroPython too is like you have like file system access. Like this has a file system on it. So I have like a JSON file that has my data on it. I have like a text file. You can read and write to it like you would on a computer.
Well, and so, even in C++, you've got that too.
Oh, do you? I haven't.
Yeah, even through the Arduino IDE.
Yeah.
So for the ESP,
but if you want to like load more code and that sort of thing.
Yeah, no problem.
Really? Huh.
Yeah, I can store files on it. I can store a file and call it as a module.
Okay. But like if you had new code?
Yeah, I can have 2 instances of code.
Okay. I didn't know that. I haven't played around with the SD cards and microcontrollers.
And then her sign serves its own website. It is accessible via our home Wi-Fi. It is using a static address that I assigned because I'm an IT guy. I got that. Okay. But it can run DHCP.
Mm-hmm.
What was I going to tell you about it?
We're talking file system writing.
It uses a real-time clock, battery backed. It pulls an NTP server. It's
why do you need a real-time clock if you can reach outwards to the internet and get it?
I need the real-time. I don't really need the RTC.
Yeah,
it's just nice to have. Okay. I don't use it for any type of timing within the sign.
Yeah.
Other than the fact that if the internet's not there for any reason, but the Wi-Fi is still up, so we have an internet outage, and the clocks on those are nice, and they're accurate enough, but I don't trust them. An RTC with a battery back is good enough that we can be without internet for 4 or 5 days, and I've got quiet hours on the sign. Mm-hmm. So she can set that at 11:30 at night. The sign doesn't actually shut down. It just turns all the lights out.
Right.
And at 6 o'clock in the morning, it turns back on. She's got different messages. I've programmed custom fonts for the displays. It has a defrost function I built into it because it's behind plexiglass. And in the winter, I put it together when it was really dry, but I could not purge all moisture out of the air, and I didn't have any nitrogen to charge it with, okay?
Right.
Or dry CO2. So there's a little bit of moisture in there, so what it does is it turns everything on in there. So it heats up. To defrost it. Now, I've got little heaters I'm going to put in it for this next part.
Oh, my God.
But it does...
Do you think that this might be a little over-engineered for a sign?
Maybe. Okay, a little bit.
I'm pretty sure you can buy just like straight up signs that like you.
But she can't sit in her living room. She can't sit in the living room and do that.
Yeah.
And I checked to get what I wanted was $4,500 for one side. Yeah, it's got a few extra features in it, maybe, but there was something about web. As a network engineer, of course, back when I started doing this, you could know every piece of software, every interrupt, every I/O address, every memory address, every DMA channel for every option card that went in an IBM Pc AT. You could know it all. That changed really quick.
Yeah.
But so yeah, I grew up in it. I have not known a day of my life without a computer. My father was a nuclear physicist. We had a computer in the basement that took up the entire basement and had cooling towers out back. And it was only a mini. Okay. It was not actually a mainframe. It was a mini computer. I've got an IBM PC in storage that has a less than 100 serial number.
Wow.
It was my dad's first PC, and it was his last computer.
Oh my God.
He retired shortly thereafter.
Yeah.
And didn't touch a computer again until, well, I shouldn't say it was his last PC. We tried to get him a PC. This is after Windows 3 came out.
Mm-hmm.
And he just couldn't figure out that mouse thing. It just made no sense to him. Give me a command line.
Right.
And now he has a tablet.
Okay.
In the past year.
Yeah.
He really did not, wasn't that he didn't embrace technology. He knows everything about the televisions and the stereos and all everything remote. He just had no need for the computer.
Right.
No, it's great for you guys. He said, you guys make it work. Just let me hit a button, okay?
He's done. He's checked out. I grew up with computers and video games and the internet, and so this is all just natural and more like, oh yeah, of course you have a tiny computer in your pocket, but
okay,
why
now
not?
but here is one thing I will tell you. I have multiple laptops, multiple many computers.
Yeah.
I've got a virtual environment that's just for Sylvie and I. It's Sandbox. This thing that I'm talking on, it is not a computer, and don't try to make me use it like one. I will shoot you down in a heartbeat. Oh, I use the interface in it occasionally. Bluetooth's nice. Wi-Fi is nice. The web page with simple controls, no problem. But that is not my computer. My computer's over there, and if I have to do big work, I'm going to a computer.
Yeah. No, I agree. Like you can't really do a lot of like you can use like the camera and that sort of thing to create content and do things on, but I'm not going to sit here and program on this dang thing.
No,
absolutely
not. Me? Okay, I actually have a secure shell client and a VNC client on my phone, and a VPN client. So if I happen to be out on the motorcycle and there's an emergency at work and I find out there's a message, I can actually go in and program a router or a switch or take care of a problem.
Restart something, rerun something.
I don't want to do it.
Yeah.
I would rather talk somebody through it.
Yeah.
I have hands at the office for that. I have people that can do it. I just need to tell them what they need to do occasionally, but no. So I love technology, but these people that are glued to these phones 24/7, they can't set it down. It's like, oh, come on.
Right.
So, if you want to use a computer, use a computer. I can understand being glued to that. But your phone?
Yeah.
Well, hey, listen.
With that said, I would love to have people control their kilns from their phone.
Absolutely. I think that's a wonderful idea, and I really do think that's a wonderful idea. You walk up, and that's where I was making the exception.
Right.
A useful app to perform a function.
Right.
I'm just not going to spend my life looking at web pages on my phone.
Yeah. All right. Well, it was great talking to you and learn a little bit more. I feel like I've learned more from you than like I've gotten out of you.
Oh no, trust me, I'm going to learn a lot about MicroPython.
All right, you better.
and so at some point, I wasn't downtown much this week, but as the summer goes on, we definitely need to actually meet in person.
Sure. I'm
and you're welcome also if you want to see a pottery studio or come play in a studio, we're going to come out here.
Yeah, that sounds fun.
All right, and so you're married. You're welcome to bring your wife too.
Okay. Yeah, she does a little bit of pottery too. Not a lot. She did a little bit like in high school, and yeah, we're both kind of artsy people.
That's good.
Yeah, it's fun.
I appreciate good art. I love looking at good art. Sylvia will tell you, I'm very honest, and I can recognize. I mean, I really appreciate what goes into art. Making it's not me, but I really can. I get it. I've got a good eye for it. I just can't do it.
It's not easy.
No.
Yeah, I went to art school I majored in computer animation and I minored in sculpture. So like I'm kind of that weird blend of like really techie, but also like really artistic. So
I can get, that's where art meets tech.
Yeah.
Programming is art meeting tech.
Like programming is great. It's like how simple, how elegant can you make this so that it runs the most efficient as possible? And honestly, like art is it can be kind of the same way where it's like, what's the idea that you're trying to get across so that people understand this? And like, I love creating experiences. Like I do a lot of like exhibit design in my day job. And I really love creating interfaces where people like you're presenting people with information so that they understand it and like guiding them down a path. And a lot of that, UX design carries through to like product design and like creating something that's really a joy to use. So that's what I really want to get across with PyKiln is something that is
simple and elegant and functional and I got it. I'm with you.
I don't want to do this clunky resistive touchscreen. Like it looks like it's straight out of the 80s. Like I don't want that. I want something modern and responsive and intuitive.
There was one. So I got to tell you this. There was one on Kickstarter or GoFundMe. There was Arduino based. This was a while ago. This was a couple of years ago. I had seen it. It looked like they were going in the right direction. And by the time I was ready to get back to it, which was just here a few weeks ago, I can't find anything about it anymore.
Yeah.
They may have gotten bought up by the competition to go away.
Maybe. I haven't heard anything from Scott or even Heat yet or anything. So,
well,
what happens?
Yeah, but you're doing open source, so you just can't go away.
Right. I mean, they can pay me to stop, I guess, but I don't want to.
But, okay, so they pay you to stop. I'll make sure I have copies of all the files. I'll start.
You'll carry the torch.
I'll carry the torch.
Yeah. All right. Well, on that note,
you have a good night, sir.
All right. Thank you. It was a pleasure talking to you.
Thank you. You too. And I'll be emailing you soon.
All right. We'll keep in touch. All right.
Yep.
Talk to you later. All right. Bye. Bye.